The idea to create a giant radio telescope emerged during the Cold War. It was the 1950s, and the world was divided not only ideologically, but also technologically. America was looking for ways to strengthen its position in defense, intelligence, and science. But it wasn't just about the arms race. It was about understanding how the ionosphere works, how radio waves are transmitted, and how to protect themselves from Soviet intercontinental missiles.
Don't forget to like, subscribe, and leave a comment. Your support helps the channel grow and motivates me to create even more amazing videos for you.
And somewhere between the lines of these objectives lay a question that has always haunted humanity. Are we alone in the universe? In 1958, the idea for a large radar instrument was born in the mind of scientist William Gordon from Cornell University. At first, his interest was purely scientific, to study the ionosphere using radio waves reflected from the upper layers of the atmosphere. But the scale of this idea impressed even his colleagues, and even more so, the United States Department of Defense. They saw its potential, a facility capable of studying the atmosphere and tracking objects in space, monitoring missiles and satellites, and possibly even listening for signals from other stars. A true treasure in the battle for technological superiority. The site for this gigantic structure had to meet several criteria: a geologically stable region, proximity to the equator for better coverage of the celestial sphere, and a natural basin that could serve as a support for the 300-meter mirror. Such a place was found in the mountains near the town of Arecibo. Construction began in 1960 and lasted 3 years. What resulted was on the verge of science fiction: 30-meter towers supporting a steel mesh mirror with a diameter of 305 meters. In the center, a platform was suspended on cables, housing the receivers and transmitters. The antenna itself was not a mirror in the usual sense. It was a gigantic grid made of aluminum panels through which tropical downpours could pass, but which flawlessly reflected radio waves. To service the suspended platform, a movable dome was installed, allowing the direction of reception to be changed. The observatory officially opened on November 1, 1963. And although from the very beginning it was created with a dual purpose, both for defense and for scientific research, its name quickly became synonymous with pure science, a place where astronomy and atmospheric physics flourished in the silence of the night sky. After its opening in 1963, the Arecibo Observatory immediately became a unique scientific facility. Thanks to the enormous aperture of its main dish, it could receive faint signals from deep space, as well as transmit powerful radio waves. This made it possible to operate both as a passive telescope and as an active radar. One of the main areas of research was the study of the ionosphere, the layer of the atmosphere that reflects radio waves and affects communication and navigation. Data from Arecibo was used for forecasting solar activity, analyzing geomagnetic storms, and studying the properties of plasma. Another important area was radar mapping of planets. With the help of Arecibo, the first detailed radio images of the surface of Venus were created. Because of its opaque atmosphere, it was impossible to do this in the optical range. The observatory also helped to refine the rotation period of Mercury. It turned out that it rotates not once every 88 days, as previously thought, but once every 59 days. In 1974, Arecibo was used to transmit the famous Arecibo message, a radio signal directed toward the Hercules star cluster. This was an experiment designed to test whether it was possible to send a signal to extraterrestrial civilizations. The message consisted of 1,679 bits of information, visualizing simple data about humanity, the solar system, and the structure of DNA. Arecibo also studied pulsars, neutron stars that rotate at high speeds. Thanks to the telescope, a binary pulsar was discovered, which made it possible to test Einstein's general theory of relativity with high precision. The observatory played a key role in the discovery of the first exoplanets in 1992. The discovery of such objects was the first confirmation of the existence of planets beyond the solar system. At the end of the 20th century, Arecibo underwent significant modernization. A new movable dome weighing over 900 tons was installed, along with new receivers and computing systems. The observatory became even more precise and efficient. In the 21st century, it was used to observe potentially hazardous asteroids, analyze the surface of the moon, and study objects in the solar system. It remained one of the main instruments of NASA and the U.S. National Science Foundation. However, with each passing year, maintenance became more expensive. Due to the tropical climate, the structures suffered from corrosion and the cables from stress. Despite repair attempts and partial replacement of components, the condition of the observatory slowly deteriorated. Starting in 2010, funding for Arecibo began to decrease. In 2011, the National Science Foundation of the United States announced that it could no longer fully support the observatory. Part of the expenses began to be covered by universities and private foundations. However, this only partially solved the problem. The wear and tear of the structures was progressing, and some components needed replacement for which there were not enough funds. In 2017, the powerful Hurricane Maria caused serious damage to the island's infrastructure. Arecibo was also damaged. In particular, the wind tore off one of the auxiliary antenna elements weighing about 9 tons, which fell onto the dish and made a large hole in it. Nevertheless, at that time, the observatory was partially repaired and it resumed operation. In 2019, the observatory was transferred under the management of a consortium involving the University of Central Florida, which undertook active promotion of the telescope. New educational programs appeared, and Arecibo itself was even used in scientific projects related to the study of Earth's atmosphere and space debris. However, in 2020, everything changed for good. On August 10, 2020, one of the main cables supporting the platform with the transmitting and receiving equipment above the reflector snapped. The cable weighed over 15 tons. Its fall punched a 30-meter hole in the dish, damaging the reflective surface and structural elements around it. Repair seemed possible. Engineers assumed that the remaining cables would withstand the load. However, on November 6th, another cable snapped, this time an auxiliary one. After the second incident, an engineering assessment revealed that the entire structure was in a critical condition. Weakening of many cables was recorded, along with significant safety risks for repair crews. On November 19, 2020, the National Science Foundation of the United States officially announced the Arecibo Observatory would be dismantled. Restoration was deemed too risky and financially unfeasible. But fate decided otherwise. On December 1, 2020, at 7:55 in the morning, the platform above the dish collapsed. It fell from a height of over 130 meters, completely destroying the central part of the dish and most of the infrastructure. Drone footage and surveillance cameras captured the moment of the disaster. An object that had been the pride of science for decades was destroyed in less than 10 seconds. After the collapse, the observatory was completely closed for scientific work. Some of the equipment was dismantled, while some was left in place. The remains of the structure were turned into a historical monument. In 2022, it was announced that a new educational and research center would be established on the observatory grounds, but the telescope itself was never restored. Over more than half a century of its existence, Arecibo made revolutionary scientific discoveries, helped us understand the universe, and left its mark on culture. It can be seen in films, TV series, and literature. It was not just a telescope, it was a symbol of humanity's curiosity. Its destruction became a painful reminder that even the grandest scientific structures require support, attention, and respect. Otherwise, even legends can disappear. Thank you for watching this video until the end. If you enjoyed this episode, don't forget to hit the like button and subscribe so you don't miss new videos. Your comments and shares help the channel grow. Let us not forget how important it is to support the armed forces of Ukraine during these challenging times. And if you have the opportunity and desire, you can support the channel financially to help create even more quality content. Thank you for your attention and support. See you in the next video.